All right, so let's determine the oxidation for zinc. So we have two reactants and this nitrate ion. So if you have an element like zinc, this element here is neutral. There's no charge. I'm sure you know what charge is. Do you guys know what charge is? Do you know what charge is?
The negatives and positive, are those the charges?
Yeah, correct. Yeah. So if you look at this element here in this chemical equation, no charge at all. So this is neutral. So if you have any element which is neutral, like the way zinc here is neutral, then the oxidation state of this element is going to be 0. So that is one of the rules for assigning oxidation numbers. Okay, so the oxidation state for zinc here is 0. Is it clear?
Yes.
Oh, wonderful. So now let's come to this nitrate ion. So this nitrate ion has got nitrogen and 3 oxygen atoms. Then we also have a negative charge. So if you are calculating for the oxidation number of an element in a particular ion like this one, this is a polyatomic ion, you must consider the charge here. So meaning the sum of the oxidation numbers of these two elements should be equal to -1. So that is also another rule for assigning oxidation numbers. So that is what we're going to apply here. Now, when it comes to oxygen, the oxidation number of oxygen is always known. So you don't need to calculate for the oxidation number of oxygen. So oxygen always has an oxidation number of -2. So it's -2 for oxygen always, except for peroxides. So peroxide is something which looks like this. Okay, so this is an example of a peroxide. Okay, yeah. So this is
Wait,
peroxide.
just a minute. So zinc
Yes.
doesn't have any oxidation number, it's 0.
No, zinc. If zinc is neutral, or if
So
you have,
zinc is zero, so that it doesn't have to.
yeah. So like in this case, you can see zinc doesn't have any charge. So
Yeah.
the oxidation number for this zinc is 0. So this also applies to any neutral element. So for example, if here in place of zinc we had carbon, and this carbon was like there's no charge, then the oxidation number of this carbon also is 0. Is it making sense?
Yeah.
Yeah. So for any element which is neutral, the oxidation number will be 0. So that is just the way it is. So um, zinc has variable valence electrons. If it doesn't have any charge, if it has a charge, then the oxidation number of zinc is going to be equal to the charge. So we'll see, like you can see the difference between this zinc ion here and this zinc here. Can you see the difference? Can you see the difference between this?
Yes.
Yeah. What's the difference?
Yes. So the difference is that on the side of the reactant,
Yeah.
zinc is neutral. On the product, it has a charge,
Powerful.
which is
Wonderful.
positive.
Wonderful. That is the difference between these two zinc. Oh, this one is an ion. In fact, this is that zinc atom is neutral. Yeah. So for the zinc which is neutral here, the oxidation number is 0. So any element in its elemental form, the oxidation number will be 0. Okay. So zinc here, the oxidation number is going to be +2. Okay. So we've just jumped these two. I'll come back to this nitrate ion. So Madam Nankamba, is it clear?
Yes.
Okay. So here the oxidation number is +2. So meaning the oxidation number of this ion is equal to its charge. The charge is +2. The oxidation number is going to be +2. Okay. Okay. Let's come back to nitrate ion. This nitrate ion has got nitrogen and oxygen. So for oxygen, the oxidation number is going to be -2, except for peroxides. So if you have a peroxide, the oxidation number of oxygen is going to be plus -1, -1. But it's rare that you're going to be dealing with peroxides. But in a case where you've been given something which is a peroxide, the oxidation number for oxygen is going to be -1. Okay, so here for nitrate, for this nitrate ion, we don't need to determine the oxidation number for oxygen because it's already known. It's always known. It's going to be -2. Yeah. So oxygen, the oxidation number is -2. So in this case, we need to determine the oxidation number of nitrogen. So the oxidation for nitrogen has to be calculated for in any compound. So to calculate for the oxidation number of nitrogen, you just put X here. So this is going to be X. Okay, so we can come up with an equation to calculate for this thing which is unknown X. So X, which is the oxidation number for nitrogen, plus we have 3 atoms of oxygen, so we're going to have 3 here. Then in brackets, the oxidation number for oxygen. So this is -2. Then according to the rules for assigning oxidation numbers, the sum of the oxidation states for,
Wait, so the 2 is the oxidation number of oxygen.
yes, this -2 is the oxidation number for oxygen. Okay, so then X plus 3 atoms of oxygen, then -2, which is the oxidation number for oxygen. So the sum of these two, the oxidation states of these two should be equal to -1, which is the charge. Is it clear?
Mm.
How we're coming up with this equation? X plus 3 atoms of oxygen plus then times the the oxidation state of oxygen should be equal to -1, which is the charge. Okay, so in other words, the oxidation state for nitrogen is going to be here to be -6 equals -1. Okay, so then we have to collect the like terms at this point. So X will be equal to -1. When this 6 crosses the equal sign, is going to be +6. The sign changes. The charge here is going to change. All right. So the oxidation number.
Sorry, sir.
Yeah. Come again.
Just a minute. Where did you get the -6?
Oh, -6. Can you?
Calculated the multiplied 3 minus 2.
Yeah.
The charge times the oxidation number of oxygen, right, sir?
Yes. 3 times -2 here is going to give you -6.
Oh, 3 times -2. Okay.
Yeah.
Nice.
Yeah. So -6 here equals -1. So then our final answer is going to be +5. So +5 is the answer here. So +5 is going to be the oxidation state for nitrogen. Is it clear up to this point?
Yeah, at least we're getting something, though personally I missed for other equations, but it's making sense.
In fact, this is the first redox reaction that we're balancing. So you're on the safe side.
Okay.
Yeah. Okay, so we're done with nitrogen this side. So we can go to the product side. This compound also NO2 here where this nitrate ion. So this is nitrite. This NO2 here, or nitrogen dioxide. Yeah. So the
So the
zinc
zinc
charge,
still remains.
zinc. Yeah, for this we have this zinc ion here. So we said the oxidation state of an ion is going to be equal to its charge. So the oxidation state for zinc is +2. Okay. Yeah. The oxidation state for zinc is +2. Is it clear?
Yeah, yeah.
Okay, all right. So again, we have nitrogen dioxide here. We don't need to calculate for the oxidation state for oxygen because it's always -2. We have to calculate for the oxidation state of nitrogen. So nitrogen is going to be X here. Okay, let me remove this so that we can have space here. Okay, then so this is going to be X plus how many atoms of oxygen do we have? There are
2
2. Yeah, so 2, then
minus.
then open brackets, then the oxidation state for oxygen, which is -2. Okay, then this should be equal to. So what is this going to be equal to?
-1.
Why -1?
This is -4.
-4, eh? So now
Yes.
look at this equation that we had here. The first one, this first one. This was x plus 3 times -2. Then this is equal to -1. What about this one? What are we going to put this? What number are we going to put here after the equal sign? So what number are we going to put here?
Is it not -4?
No, it will be 0.
That is 2 times 2.
No,
Oh,
yeah.
yeah.
Before multiplying, we need
Tester,
to
why
have
are
a
we
number here.
putting 0?
It's here. So here it will be 0. Why am I putting 0 here? Because of the rules for assigning oxidation numbers. So there's a rule which says that the sum of the oxidation states of elements in a given compound should be equal to its charge. So if you look at this nitrogen dioxide here, it doesn't have any charge. The charge is 0. So the oxidation state of nitrogen plus oxygen should be equal
What
to
the cost
0.
of the card? Oh, yeah, now I get
Yeah,
it.
yeah. Well, here for this nitrate ion,
It had
it
the charge.
had a charge, so that's why we put -1 here.
Yeah,
So I hope that is clear.
yeah, it is.
Okay. So are we on the same page?
Yes.
Okay.
I lost you at some point. I don't know if it is my network. I don't know if you may repeat
Oh yeah, I was trying
on
to
how
explain.
we are finding this.
Oh yeah, I was trying to explain why we have 0 here. So what it means here is that the oxidation state for nitrogen plus the oxidation state of oxygen should be equal to the charge. Now, if you look at this nitrogen dioxide here, there's no charge. So if there's no charge, it means that there's 0. So that is why we have x plus 2. Then this is 2. In brackets, we have -2, the oxidation state for oxygen. Then this should be equal to 0. While here, for the nitrate ion, we had a charge of -1. So we had x plus 3, then in brackets, we had -2. Then this is equal to -1. So are you able to see the difference between these two equations? This equation here and this equation here. Mr. Muito? Yes, Mr. Muito.
Yes, yes, I lost you at some point. So in short, what you are saying is it's the same thing with zinc, where we said it's neutral. So the same thing with nitrogen is also neutral.
Yeah, yes, the compound is neutral. The compound is neutral. So if
Okay.
when calculating for the unknown, uh, the sum should be equal to 0 because this is neutral.
Okay.
Okay, all right. Yeah. So we can do the addition and subtraction. So we have x plus 2. So this is going to be x minus 4. What so? X minus 4 is equal to 0. All right. Then we know what to do here. Since we're calculating for x, we must make x the subject of the formula. So this 4 is going to go to the other side. Then this is going to be plus 4. All right. So the oxidation state for nitrogen here is plus 4. Is it clear?
Yes.
Yes, yes.
Wonderful. Yeah. So this is our first step um, for balancing redox reactions. So we have determined the oxidation numbers. The next step, so I can add this, I can type here. So I need to get the text box. Then, yeah. So step number two has to have equations. So have reactions. Let me have reactions. So first step, you determine the oxidation numbers. Second step, you must get the half equations from this full equation. So let's see how we can do that. How can we get the half equations? This is how you do it. So this is how you do it. I need to move this side. Then I'll need to create some space here so that we can, write some stuff. So I'm just removing these things here. Removing these things here. Yeah. Okay. So let's look at zinc. Zinc, this side has an oxidation number of 0. Then this side, the oxidation number is +2. Can you see that?
Yes.
Wonderful. So if you define oxidation in terms of oxidation state, oxidation is defined as oxidation type. Oxidation is the increase in oxidation states. Yeah. Then reduction is the decrease in oxidation state, right? This is this is the definition for oxidation in terms of oxidation state. So in actual sense here, zinc is undergoing oxidation, all right? Because there is an increase in the oxidation state from 0 to +2. This is oxidation. If you look at nitrogen here, the oxidation state is +5. Then here, the oxidation state is +4. So this is reduction. So this is reduction. So these are going to be the two half equations. So we're going to have the oxidation half equation and the reduction half equation. Is this clear? Is this making sense?
No.
Okay. Mr. Moitwa, are you with me?
Uh, yeah, we are with you. The only challenge we have is that we missed the first balancing equation, but we're getting something though at some time we are stuck. What I got is that for zinc,
Uh-huh.
it's increasing, the oxidation is increasing.
Yeah,
Then for nitrogen, it is reducing.
correct. Yeah. So what I'm trying to do here, I'm trying to come up with two half equations. So for you to come up with the two half equations, you have to look at the oxidation state. So for you to get the oxidation half equation, you have to look for a situation like this one, where we have oxidation number of 0, oxidation number of 0. Then on the product side, the oxidation number is +2. So in actual sense, there's an increase in oxidation state of zinc here. So meaning this is oxidation. Zinc is undergoing oxidation, while nitrogen is undergoing reduction because there's a decrease in the oxidation state of nitrogen from +5 to +4 here. So this is going to be the oxidation half equation. I'll write it. Then this is going to be the reduction half equation. Madam Nankamba, are you there?
Yes, I'm there, sir.
Okay. Where are you stuck concerning this step?
Maybe
I'm
as you
stuck on
go,
the reactions.
On the half reactions.
Yes, how do you come up with half reactions? Well,
Okay,
when
yeah.
you're explaining something about it.
Yeah, so I was trying to say that for you to come up with the half reactions, you have to look at the oxidation numbers of the reactants and the products. So you look at elements other than oxygen. So you don't have to look at oxygen. You look at other elements apart from oxygen. So in this case, we have zinc
Also,
and nitrogen.
nitrogen.
Mhm. So you compare the oxidation state of these two elements on the reactant side and also on the product side. So for zinc, the oxidation number is 0 on the reactant side. On the product side, the oxidation number is +2. Can you see that?
Yes.
Yeah, so if you have a situation like this one, it means that zinc is undergoing oxidation. Then for nitrogen, the oxidation number is +5 here. Then this side, the oxidation number is +4. So from 5 to 4, there's a reduction there. So that means that nitrogen is undergoing reduction.
So nitrogen is undergoing reduction, then zinc is undergoing oxidation.
Yes. So this is the definition for oxidation and reduction in terms of oxidation state. It's here. Oxidation is the increase in oxidation state, while reduction is the decrease in oxidation state. Okay.
Yes, sir.
Okay. So now let's come up with half equations. So let me just create space here. So again, I need to undo. Then just remove everything here. Then these rules can be somewhere this side. Okay, then I'll need to create space here. Oh, yeah, we need to create space here so that we can. All right. Okay. So we're going to start with zinc. So Zn, this is giving us Zn 2 plus. Okay. I've just gotten this from this equation here. Zn is giving us Zn 2 plus. Then NO2, NO3, not NO2. This is NO3 minus is giving us NO2. These are the two half equations. Okay. So zinc to this. Then NO3 minus that one, NO2. Are we together?
Mm-hmm.
Okay, yeah. So now we have the two half reactions. What should be our next step? So we are now on step 3. Step 3. So let me write the third step. Step 3 is to balance now.
They have reactions.
Yes, step 3, balance. Balance the half reactions. Balance.
sorry, sir, before you proceed,
Yeah.
before you proceed, on the nitrogen,
Okay.
just for the sake of learning, why didn't you write n plus 5 to n plus 4 as a reduction? So I don't know where you got.
Yeah, so PS plus 5 is the oxidation state for nitrogen. So the oxidation states are just helping us to come up with the reduction half equation and the oxidation half equation. So when you have the half equations, you don't need to indicate the oxidation states.
Okay, okay. So meaning where are you getting the NO3?
Or NO3, here, this is NO3. When just rubbing, I removed part of the 3 here. So it's the NO3 here.
Oh,
Yeah.
okay, 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 okay.
So
See.
NO3, then
Oh,
NO2 here.
okay, that's noted.
Wonderful, wonderful. Okay. All right. So third step, balance the half reactions. So let's put this aside, this side. Let's balance these half reactions. So you're supposed to balance the half reactions in terms of number of atoms. That is one thing. Then you also balance the charge. So balance number of atoms, then balance charge. Two things. Let's start with the oxidation half reaction. So also one zinc. So zinc is balanced. Not so. We don't need to balance anything because zinc is balanced here. So number of atoms for this oxidation half reaction, the number of atoms are balanced. Okay. So number of atoms balanced for the oxidation half reaction. Now let's come to charge. So for you to balance charge, you have to look at the charges of the chemical species. The chemical species. So we have zinc here, which is neutral. So the charge here is 0 for zinc. Then we have this zinc ion. The charge is 2 plus. So the overall charge on the product side is +2 for zinc. Then the overall charge for zinc on the reactant side is 0. So charge is not balanced. So now what do you do to balance charge? What do you do to balance charge? So for you to balance charge, you have to add electrons. So maybe I can write this point here. So to balance, to balance charge, add electrons. Is this clear? We are yet to add electrons. Just wanted to make sure that you understand that charge is not balanced.
Or the charge on the other zinc and the other zinc.
Yes. Okay. Yeah. So let's balance charge. So to balance charge, add electrons. So which side are you supposed to add electrons to? To which side are you supposed to add electrons to? It's the side which is more positive. So you always
The
add
one which
electrons.
has more positive, that's why you add electrons.
Yes, yes. So 0 then +2, like 2 is more positive. Look, yeah, we have a bigger number this side. So that's why you add electrons so that you reduce it. Okay. So let's add electrons. First of all, before we add electrons, I need to remove this number here so that we can have space. Okay. So I'll add 2 electrons this side plus 2 electrons. Okay. So electrons are negatively charged. So in essence, the overall charge is going to be 0 this side, which is same as the charge on the reactant side. So this is the overall charge here is now 0, same as this side. Is it clear? On balancing
Yeah, so
charge.
in short, in short, you have added -2 to
Yes,
zinc.
yes,
Uh,
I have added -2.
okay.
So meaning if 2 is going to, the overall charge is going to be 2 plus -2, which is going to be 0.
So then we've balanced it.
Yes, charge is now balanced. Okay, we can proceed to the next half reaction, right?
Mm-hmm.
Okay, All right. So the oxidation half
Sorry,
reaction is
sir.
balanced. Yes, sir.
Sorry, sir.
Oh no, it's okay. Yes.
So in other ways, what you are saying, these charges, it's more or less like the way you deal with the polyatomic ions, where you deal with the charges.
Well, the charge is yes, because it means that
Like,
the charge for zinc here, this we have one here, so it's going to be one times this superscript. So one times this is two, then plus two here, negative two. It's going to be zero.
okay, okay.
Yeah. Okay. So let's also balance the reduction half reaction
Right,
here.
so do you always have to add two? Or it's depending on how many charges you have on that when you're like balancing enough equations.
Oh yeah. So it depends on the number of whatever. It depends on the charge, the positive
You
charge
have.
that you have. Yes.
Okay, so if you have three, you add three.
Yes. No, because sometimes here you can have plus two, and maybe here you can also have plus one. So if you have, let's say for example here we had an overall charge of plus one here. Then
Mm-hmm.
here we have plus two. Then it means that we're supposed to add negative one so that we have the same charge.
So you have to add something which will balance the other, right? Like which will
Yeah, which is going to
help you
balance the charge.
balance.
Yeah.
Mm-hmm.
So you always have to reduce the big number. So the side which is more positive has to be reduced so that it can be equal to the other side which is less positive. Okay.
Mm-hmm.
All right. Yeah. So let's balance now the reduction half equation. So we'll start with the number of atoms, then we'll balance charge. So yeah, let's start with nitrogen. How many atoms of nitrogen do we have?
One.
One atom. Yes, this side. Then this side, how many?
One also.
One also. So nitrogen is balanced. Okay. Let's move to oxygen. How many atoms of oxygen do we have on the reaction side?
Three.
Three. What about on the product side?
Two.
So oxygen is not balanced. Okay. So oxygen is not balanced. So now what do you do to balance oxygen? So I'll write what you need to do here. So to balance charge, we know we're supposed to add electrons. So now if you're balancing oxygen, you add water. Okay.
We add
So
what?
you add a water molecule. So I'm just writing this down. So to balance oxygen, add H2O. So this point is right here. Let me just
Add the
drag it.
molecule.
Yes, add a water molecule. To balance oxygen, add H2O. Can you see this? So this is supposed to be a subscript. So 2H2O. H2O, yeah, water molecule. Yeah. Yeah. So let's,
Sorry, sir, before you proceed,
yeah.
what's the difference between a superscript and a subscript?
Oh, okay. So if I write something here like this is H, H, then this two is down here. Can you see it? This is a subscript.
Yes.
H2O, the way you write what the formula for water molecule. So this two here is a subscript. Well, if like for zinc here, this is a superscript. Like this number is on top of this symbol. Superscript. Yeah, superscript. Then subscript here.
Okay,
Is
so
it
now what's the difference? Maybe of atoms or electrons or ions, I don't know.
in terms of what? So for charge, we have to consider the superscripts only.
Okay, okay,
Yeah, yeah. For charge, you consider the superscripts and their coefficients.
okay.
Yeah. Okay, so let's balance this reduction half equation. then you'll be able to see uh, how we can balance the charge also for this by looking at the superscript and the coefficients. Yeah, so we have 3 oxygen atoms this side, then this side we have 2. Okay, so the side that needs to be balanced is this side where we have less. So we're going to add a water molecule this side. Yeah. uh, yeah, so we're going to add the water molecule this side. We have 2 oxygen atoms, then this side we have 3 oxygen atoms. So it's going to be H2O, H2O, right? Like this. So I've added the water molecule to balance oxygen. So oxygen is now balanced because we have 2 oxygen atoms here plus 1 oxygen atom from the water molecule. So we have a total of 3 oxygen atoms this side, then also this side, 3 oxygen atoms as well. Is this making sense? Madam Nankamba and Mr. Muitwa?
Yeah, sorry, sir. On the oxygen 3 atoms, you are saying you also need to add the water or what?
So we are trying to balance the number of atoms here. So we first of all started with nitrogen. So nitrogen, we checked nitrogen, we had 1 atom of nitrogen this side.
Sorry, sir, but I can't hear anything. I don't know if you can hear me.
I'm able to hear you. You can't hear me? Mr. Muitwa, can you get what I'm saying?
Yes, yes.
Then it means that is Madam Nankamba. Okay, so yeah, wish she had network challenges, but she's back. Yeah. Madam Nankamba, are you able to hear me now?
Okay, yeah, now I can.
Wonderful, wonderful. Yeah. So I was saying we're trying to balance the number of atoms. We're trying to balance the number of
Mhm.
atoms. So as you can see, nitrogen is balanced because we have 1 atom of nitrogen on the reactant side, then also 1 atom of nitrogen on the product side. So nitrogen is balanced. We don't need to add any coefficients. Then we moved to oxygen. Then for oxygen, we actually saw that oxygen had 3 atoms on the reactant side, then 2 atoms on the product side. So this means that oxygen is not balanced. So what I said was that in order to balance oxygen, you have to use water molecule. You have to use a water molecule. That's how you balance redox reactions. For you to balance oxygen, you are supposed to add a water molecule. So this only applies to redox reactions only. So Mr. Muitwa, is this making sense now?
Yeah, yeah. So we're adding water molecule to balance to oxygen. So maybe as we proceed also to know for the 3 atoms of oxygen what happens.
Okay, yes. So now we had 2 here on the product side, 2 oxygen atoms. So we're supposed to add a water molecule this side so that we can have 3 oxygen atoms, because we need to have the same number of atoms on the reactant side and the product side. So by adding a water molecule, I've balanced oxygen because I now have 2 atoms here, 2 atoms from this compound, then plus 1 atom from this water molecule. I have a total of 3 oxygen atoms.
That is well noted.
Oh, wonderful, wonderful. Yeah. Yeah. So now by adding a water molecule, we have introduced hydrogen to this equation. Can you see that?
Yes.
Oh, yeah. So we need to balance oxygen as well. So to balance hydrogen, you have to add H plus. So this is how you balance redox reactions. To balance oxygen, we said you add a water molecule. To balance hydrogen, you have to add H plus. This H plus that I've written here. This is what you add to balance hydrogen. Okay. So we have 2 hydrogen atoms on the product side. So meaning we also have to add two H plus ions on the reactant side. Are we together on this one? So I have added two H plus ion on the reactant side as well to balance hydrogen. Are we together?
Yes, yes.
Okay. Okay, so we have balanced the number of atoms for the reduction half equation. We now need to balance, the charge. So after balancing the number of atoms, we need to balance the charge now. So what is the overall charge on the reactant side? What is the overall charge? Tell me the overall charge on the reactant side. What is the overall charge?
That's zero.
Zero. Why is zero?
We don't have N. I don't know. I can't see N electron on top there.
Okay, so yeah, so this is our charge here. Can you see for H plus ion, this is the charge. I've circled the charge here. Then we also have this charge here. Can you see these two things? These are
Yeah, yeah.
our charges. So now we also have to consider the coefficient. Look at this H plus ion. It has got these two in front. Can you see these two here?
Yes.
Yeah. Then for this nitric ion, there's nothing. Meaning if there's nothing, we can assume that we have one. Okay. So
Yeah.
the charge is going to be calculated as follows. So it's going to be 2. It's 2 times this charge, which is plus 2. Okay. Then plus 1 times this negative charge. So it's going to be negative 1. Okay. Mr. Muitwa, are you with me?
Yes, yes.
Yeah.
Yes.
Yeah. So meaning this is going to be, the overall charge is going to be, okay. So our overall charge is plus 1 on the reactant side. Is it making sense now?
Yes.
Okay, okay. So the overall charge here is plus 1. Let's look at the product side. What is the overall charge on the product side? What is the overall charge? What is the overall charge?
I don't think if we have N charge there, if I'm not mistaken.
Correct. There's no charge. Yeah. So the overall charge is 0 this side. So charge is not balanced because here we have 0, then this side we have 1. So what are we going to do to balance charge? What are we going to do to
We
balance
have
charge?
positive 1 this
Positive
side,
1.
right?
Yes. On the reactant side. Yeah. So what
Now
are we
we
going to
add
do to
negative
balance it?
1.
Correct. Correct. Thank you very much. Yeah. So we're going to add negative 1, which is 1 electron. Okay. So we have balanced our reduction half equation in terms of number of atoms and also in terms of charge. So both half reactions are balanced in terms of number of electrons and number of atoms and also charge.
So it would be 2 hydrogen plus nitrate equals to is it nitrite and water?
Yeah, yeah. So far. Okay. So yeah, so we're almost done. After now balancing these two half reactions, we have to look at the number of electrons. Okay. So you look at the number of electrons, then you make sure that you have the same number of electrons in both half. Like the number of electrons should be the same for both half reactions. Okay. What is the number of electrons for the oxidation half reaction? How many electrons do we have? How
Where?
many electrons for the oxidation half reaction? How many electrons do we have? Can you see the
I
number?
will only have one.
Come again?
Is it not just one on the hydrogen?
Yes, for this, yeah, you're right. This here we have one, then here we have two. So the number of electrons should be the same before we add the two half reactions, because the next step here is to add the half reactions. But before you add the half reactions, you need to ensure that the number of electrons is the same for both half reactions. So now what we have here is that we have two electrons for this oxidation half reaction. Then we have one electron
Are we
for
going back
reduction.
on zinc or we are still on the nitrate?
No, we are on this reduction half equation and also the oxidation half equation. So we're still looking at both equations.
Okay.
Okay. All right. So now, can you see that the number of electrons is not the same for these two reactions? Can you see that?
Yeah.
Mhm. So if the number of electrons is not the same, you have to make it the same. How do you do that? Here you have two, okay? So you multiply this equation by 1, okay? Then this equation should be multiplied by 2, all right? So I've just one electron. So this one multiplied by this half equation. These two here are going to multiply this half equation so that we can have the same number of electrons. Is it clear? Is it clear why I've chosen 2 and 1 here?
Yes. Yeah, you said balancing so we can have the same electrons on the same half equations.
Correct, correct. Yeah, yeah. So let's multiply. Let's multiply this half equation. So if we multiply this half equation by 1, nothing is going to change, all right? So we won't change anything because what we have here is 1. Now 2 times 2 here, what are we going to get? It's going to be 2 electrons, not so? 2
2
electrons
times
here. 2 times 1 is 2, right?
2.
Yeah, 2. 2 times 2 here. 2 times 2,
4.
4. Yeah, 4. So yeah, what about here? So 2 times 2 here, this is going to be 2. 2 here, okay? Then again here to be 2. Here it's going to be 2, all right? So this is what we're going to get. So now we have the same number of electrons. Can you see that? 2 equation. So now since the number of electrons are the same, we can now add the two half reactions. We can now add the two half reactions. All right. So we can do the half reactions. Okay, so let me remove this, then also remove this so that we can have enough space here. We need space, so we'll need to remove this here. Okay. Yeah, so I can draw this line here. So we can cancel the things that are appearing on both sides of the equation, like both sides, like we have 2 electrons here, we can cancel this, then also 2 electrons here. All right. Okay. Are we together? We're adding here. We are adding the two half reactions. So I've cancelled the number of electrons. From this side and
Sorry,
also
sir.
yeah,
Just,
yeah. You
so
can
I
ask.
noted on the reactant side on nitrogen, you cancelled the hydrogen
I cancelled hydrogen.
and wrote, I don't know if I'm mistaken, you cancelled the hydrogen and wrote 2.
Yes, because we are multiplying this whole equation by 2, because we needed to make sure that we have enough electrons. So we are multiplying this whole equation by 2.
Okay, okay, okay.
Yeah, so we had 2 there. 2 times 2 is 4. Then I've multiplied everything in this equation by 2. Okay.
That's noted.
All right, wonderful. So now we're adding the two half equations. So I've cancelled the number of electrons because they are the same here. Okay. So we can write zinc. In fact, this is our last step. Zinc here, then plus 4H plus, 4H plus, 4H plus, then plus NO3, NO3, NO3 minus. Okay. So we're done with the reactant side for both equations. You can see zinc plus 4H plus, then plus 2NO3. Then we can come this side. Then we have Zn2 plus, Zn2 plus, then plus this 2 here, 2 NO2, 2, then plus 2 water molecules. All right. Yeah, 2 water molecules. Yeah, so this is our final answer. That is how you balance redox reactions in acidic media. So once you get this equation, you're supposed to counter check the number of atoms and also check the charge. So let's counter check. We have one zinc atom balanced. We have 4 hydrogen atoms this side. Then this side we also have 4. You can see 2 times 2 is 4. It's balanced. One nitrogen atom. Then, oh, we omitted these 2 here. Okay. So yeah, I omitted those 2. We had 2 here. They need to be plus. Then these 2 here. All right. So 2 nitrogen atoms, 2 nitrogen atoms. Then we have 2 times 3, 2 times 3, 6 atoms of 6 oxygen atoms. Then 2 times 2 here, 4 oxygen atoms plus 2 gives you 6 oxygen atoms. Right. So the number of atoms are balanced. This equation is balanced in terms of atoms. You also have to check charge. So on the reactant side, we have 4 minus 2, which is giving you 2 plus. So the overall charge this side is 2 plus. What about on the product side? The overall charge is also 2 plus. So this equation is balanced. This equation is balanced. So this is how you balance redox reactions in acidic media. So the first step is to determine the oxidation number. Second step, you get the half reactions using the oxidation states. Then the third step is to balance the half reactions in terms of atoms and also in terms of charge. After you balance the half reactions, you make sure that the number of electrons are the same. The number of electrons are the same for both half reactions. After that, you add the two half reactions, then you get your overall answer. Then you have to counter check, ensure that the number of atoms are balanced on, ensure that the number of atoms are balanced on the reactant side and also the product side. Then you also check your charge. That is how you do it. Are there any questions? Because I'm sure it's time up, in fact, now. 14, 14, 15, according to my time. Are there any questions?
No, 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 no.
No questions?
But on the LMS, where I'm unable to access the modules.
Oh, you're unable to access the
Saying
modules.
my session is expired.
You can discuss with the student mentors. I don't know, who's your student mentor?
Mr. Aaron Skanyuka.
Yeah, just talk to him. He's going to facilitate.
Okay.
Yeah. Any more questions or concerns?
No, 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 no.
Okay. All right. Okay. Good day.
So,
Meet
sir,
again. Yes, sir.
Hello?
Hello.
Hello? Yeah,
Yeah.
so for me, the only concern is I don't know, for the recordings. We have been requesting for recordings, but we haven't been given an access to the recordings.
Oh, okay.
Yeah, why I say so?
Yeah.
So just ask Mr. This